Hi, this is Cathal O'Leika on Principle Sheet 1. With the areas of figures principle sheet. First we're going to look at the proof of the area of the triangle. So a good way to start off with the proof of the area of the triangle is to use the area of a rectangle to quickly derive the area of the right angle. So if we start off with a rectangle, and we'll call it A, B, C, D. And we know the area of a rectangle, we'll call this H and we'll call this B. So this is the base and this is the height. And we know that the area of a rectangle is B by H. So if we draw a line from A to C, we can see that that's half of the rectangle. Each section is half of the rectangle, and what we've also done is we've put in two triangles. So we know that the area of the triangle is half the base by the height. For example, the area of the triangle ABC is half B by H. Although this makes sense, the proof is incomplete because triangle ABC is a right angle triangle. So how do we know this formula will work for any triangle such as an isosceles or equilateral? So if we have two parallel lines with the same base, we know that any triangle with the same base and the same height we know all these triangles will have the exact same area because they'll all have half the base by the same by the height. Next we're going to look at converting a polygon into a triangle of equal area. We've already done this by manual drafting in the lab. So we can see here we start off with our polygon, our pentagon, 5 equal sides. So what we did then is we started off from our apex, we joined it down to the corner here, and from that we drew a line, and from the point out here we drew a parallel line, and then we can join this back to the apex and do the same on the other side, and that gives us a triangle of equal area to the polygon. And to prove this, we proved it over here. Here we have our triangle, and we just use our formula, half the base by the perpendicular height, and that gives us 45 by 60 is 2790. And using the measurement here, area of triangle, we converted the polygon into 5 triangles. Then we broke them 5 triangles into right angles. We broke them all into triangles. And with this formula again, half the base by the height, we got 20 by 28 is 560. So each one of these is 560, and we multiply that by 5 and we got 2800. Because we drew this out with pencil and T-square, there was a 10mm difference just due to the inaccuracy of the drawing. We also used mathematical theorem to calculate the area, which was with tan opposite over adjacent, and we worked it out that way, and we had a small difference as well, but this is all just due to the inaccuracy of the drawing. Next we're going to look at converting a triangle to a rectangle of equal area. Here we have our triangle, and we know again with our half the base by the perpendicular height, half the base of the triangle by the height gives us the area of the triangle. And we also know that if you put a rectangle around a triangle and simply half the rectangle, the resulting rectangle is of equal area to the triangle. Half the base of the triangle by the height is the area of the triangle. Yet half the base of this rectangle by the height is the area of this rectangle. So we know that if we go halfway on the base of the triangle with the same height, that will give us a rectangle of equal area. And we can also create a rectangle of equal area with a specific ratio for its side lengths. If we want to break the rectangle of equal area in the ratio of 3:4, so if you look here, we drew a small rectangle of any size with 4 units for its one length and 3 units for another length. And with that then we got the mean proportional of this small rectangle. We brought our line, or we radiused the arc back here, got the centre of the small one and brought back up this point, and that gives us the mean proportional of our small rectangle with the units 3:4. From there we drew a line back to the corner of a small rectangle, and having done the same process with our original rectangle, we get the mean proportional, which ends up here. From this line connected to the mean proportional of the small one, if we go parallel from the mean proportional of our main rectangle back out here through the diagonal of the small one, that gives us a rectangle in red of equal area, and it's also in the ratio of 3:4. Now we're going to look at converting a rectangle to a square of equal area. So if I draw a rectangle here, 90 by 40. I'll use these figures as it's easier to prove that we're correct. 90 by 40. Let's draw a line out here. So we get the mean proportional of this rectangle. Now we've been down this point, we just get the centre point now of the whole lot, the midpoint. That's our centre point, and now we can get the mean proportional of our rectangle. And because this is 90 by 40, 9 by 4, it's 36, we should have a square now, yeah, and that's 60. So we know that this rectangle is converted into a square of equal area. That's 6 by 6, that's a square, and 4 by 9 is 36, 6 by 6 is 36, so there we have our square of equal area to the rectangle. Thanks.